Hello, we are on chapter 2, section 2.5, compound inequalities. And the first objective today is to find the intersection of two sets. And when we talk about intersection, we are talking about the word and. That means we're usually going to talk about sets of numbers, right? Let's say we have the set A, the set B, and we want to know the intersection between A and B. If we say A and B, this means intersection. This means this can be represented as A, and this symbol here, this like a U upside down, A intersection B. And what means A intersection B? Basically, you have this set, you're going to represent as a Venn diagram, is A, this is going to be A, and another set here, which is going to be B. And this common area here, the set of numbers that belongs both to A and to B, this is going to be the intersection, right? The example that we have here is to find the intersection of the set of numbers 2, 4, 6, and 8, and the set of numbers B at 3, 4, 5, and 6. And let's represent here as this one. Suppose this one is A, and A is 2, 4, 6, and 8. And we want to know the intersection. This representation is the U upside down with B, and B is 3, 4, 5, and 6. So let's write here, let's represent here on the diagram. 2, the number 2, can you find on set A? Yes. Can you find on set B? No. That means, let's open some space here, that 2 is here on this side. Number 4. 4 is on the set A and on the set B as well. So you can write number 4 here in the middle, is this area that belongs to both sets. Number 6 also belongs to set A and set B. So number 6 is here. Number 8 belongs only to set A. And let's have a look at the set B. We have also number 3 that belongs only to set B. 4 is here, 6 is here, and 5 belongs only to set B. So what's the answer if I ask what's A, this set here, intersection that set there? This is going to be equal to 4 and 6. Objective number 2, solving compound inequalities containing and. Let's go straight to an example. If we have x plus 4 greater than 0 and 4x greater than 0. Remember that this word here, and, means intersection, right? The first thing, we're going to solve each inequality separately, So x plus 4 greater than 0. Subtract 4 on both sides. Addition property of inequality. X greater than negative 4. And for x, let's split here the screen. For x greater than 0, divide both sides by 4. That means x greater than 0. Here on the bottom, let's represent the graph first of x greater than negative 4. So let's say here is 0, 1, 2, 3, 4, negative 4. And x is greater than negative 4. We don't have an equal sign here, it's just greater, right? So we have we're going to represent here with a parenthesis. That means that negative 4 is not included on the sets. And this goes all the way to infinity, positive infinity. And the other set, which is x greater than 0, let's represent down here. And let's align zeros. 0 is there. X greater than 0 we can represent using a parenthesis because we don't have an equal sign here. 0 is not included on the set, and this goes all the way to positive infinity. And what we need, what we want here is the intersection. That means all the set of numbers that belongs to one set and the other. That means to both sets. And we will represent here, this is the intersection. 0. This is the representation of the intersection. Does 4 belongs to any set? Actually, 4 doesn't belong to the first set nor the second set. So 4 is out. Does everything between negative 4 and 0 belongs to both sets? Have a look here. No, it just belongs to one set, to the first set, right? Doesn't belong to the second set. So this set of numbers between negative 4 and 0 is out. The 0 belongs to both. 0 is included in both sets. Actually is included here, but is not on the second set. The parenthesis means 0 is not included on the second set. So is not included on our intersection either. And everything between 0 and positive infinity, you can see it part belongs to both sets. So we're going to represent here, this is our intersection, and represent the intersection in interval notation. We can write parentheses because 0 is not included, 0, positive infinity. And every time when you have infinity, you also use the parentheses. So the answer here to graph the solution for x plus 4 greater than 0 and for x greater than 0 is going to be this graph here that we can represent also in interval notation as 0 parenthesis 0 comma positive infinity parenthesis. Let's move on to another example. Now we have this inequality that we have to solve. 0 is less or equal than 4 times 5 minus x, which is less than 8. And when we have something like that, that means that 4, check this here, 4 times 5 minus x, this is the expression, right, is going to be greater or equal than 0, and 5 minus x is going to be less than 8. Is an intersection between this and that. Okay, let's work with the expression, with the representation as shown here. The first thing we're going to use distributive property. So 0 is less or equal than 4 times 5, 20, minus 4x, which is less than 8. Now we can apply the addition property, adding negative 20 on all 3 sides of this inequality. So negative 20 here, negative 20 in the middle, and negative 20 here at the end. So we will have 0 minus 20, negative 20, less or equal than 20 minus 20, 0, negative 4x is less than 8 minus negative 20, negative 12. Now we can divide all the inequality by 4. We can divide the whole inequality by 4 better. We can divide by negative 4, negative 4. And remember, when we have an inequality and you multiply or divide by a negative number, you have to flip the inequality, right? You have to flip like this, the inequality. So negative 20 divided by 4, 5, negative 4x divided by 4x, and negative 12 divided by 4, 3. That means x is between 3, x is going to be greater than 3, and x is going to be less or equal than 5. Graph the solution. Draw here the line, and this line goes to positive infinity to negative infinity. Here in the middle, we're going to have 0, and let's represent x is going to be greater than 3. Let's say 3 is here, 1, 2, 3, 4, 5, and 5 is here. So x is going to be greater than 3, but 3 is not included because we don't have an equal sign here, right? Draw a parenthesis. And less or equal than 5. Here you're going to draw this bracket because 5 is included. There's this equal sign here, see? 5 is included. Everything between 3 and 5 is also included on the sets. You can represent here also the interval notation, parenthesis 3, comma 5, bracket. And this is the answer to the inequality. 0 is less or equal than 4 times 5 minus x, which is less than 8. Okay, another example. Now we have the following inequality. 2 is less than 4 minus x is less than 7. First thing we're going to do here is apply the addition property of inequality, and we will add negative 4 to all sides here of the inequality. So we will have 2 minus 4, negative 2, less than 4 minus 4, 0, negative x, which is less than 7 minus 4, 3. Next step, divide by negative 1 or multiply by negative 1. It's going to be the same thing. But remember, you have to flip the inequality. When you're dividing or multiplying by negative 1, flip the inequality. Negative 2 divided by negative 1 is 2. X divided by negative 1, x. And 3 divided by negative 1, negative 3. And this is the result. And remember, you can say here 2 is greater than x, which is greater than negative 3. Or you can also say it's the same thing, it's going to be the same thing. Negative 3 is less than x, which is less than 2. See, it's the same thing. And we will represent here the graph negative infinity, positive infinity, 0 here in the middle. And let's say you have here 1, 2, this is 2, 1, 2, 3, and that's negative 3. Thus, negative 3 is included on the set. Check here. The inequality is just less than. We don't have less and equal or equal. So since we don't have the equal sign here, is parentheses. And on the side of the 2 is the same thing. It's less than 2. There's no equal sign. Again, parentheses. And everything in between will be included is part of the set. We also can represent this as using interval notation. Parentheses negative 3, comma, 2 parentheses. We are on objective 3 now, finding the union of two sets. Well, we've seen before that when you see the word and, we are talking about intersection, right? Intersection. Now we will see union. And union is the word or. Or, when we see the word or, we are talking about union. Let's say we have two sets. Usually we're talking about two sets of numbers. And then you have set A. This is the representation, the Venn diagram of set A. And set B. And this is the diagram of set B. The union of two sets, A and B, is the set of elements that belong to either of the sets. That means the union is the whole thing. The whole thing is going to be the union. A or B. And the representation, when we're talking about union, is A. This is the sign, is a capital U, looks like a capital U. B. And let's apply this new knowledge to an example. If we have these two sets of numbers. One set, let's say set A is 2, 4, 6, and 8. This is set A. And set B is going to be 3, 4, 5, and 6, and this is set B. Let's draw the diagram of A. We have here A, and we have here B. Inside A we have 2, 4, as you can find 4 in A and B, so 4 is here. 6, you can find 6 in A and B, and 8. And B is 3, 4, 5, and 6. So what's going to be A union B? As we have seen, A union B is the whole thing. Let's write down here in green, or let's say purple, which is 2, 3, 4, 5, 6, and 8. So A union B is equal as this set with all the numbers that are either in A or in B. Excellent. Now we are ready to go to the next objective, objective number 4. Solve compound inequalities containing OR. And the first example here, solve. If you have the inequality 5 times x minus 1 is greater or equal than negative 5, or what's OR? What's the meaning of OR? Or 5 minus x is less than 11. Again, remember, when we are using the word OR, we are talking about union. And let's first solve for each inequality. First here, let's calculate the distribution. Negative 5. Let's add 5 on both sides. Add 5 on both sides, then you have 5x greater or equal than 0. Divide both sides by 5, then you have x greater or equal than 0. And now this one, 5 minus x less than 11. Subtract 5 from both sides, then you have negative x less than 11 minus 5, 6. And divide or multiply both sides by negative 1. Then you have, don't forget, when you're dividing or multiplying both sides by negative 1, you have to flip the inequality. X is greater than negative 6. Okay. Next step is to find x is greater or equal than 0, or x is greater than negative 6, the union. And one thing that's really helpful is to draw here the graph. Let's say here 0, and this graph goes to positive infinity, from negative infinity to positive infinity. And the first one is going to be x is greater or equal than 0. See, there's this equal sign here, so let's draw a bracket, because 0 is included in the set, and everything that's greater than 0 is also included. Everything to the right side of 0 up to positive infinity is included. So this is x is equal, greater or equal than 0. The next one that we will represent here is x is greater than negative 6. So here 0, positive infinity, negative infinity. And now we move here to the left. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Negative 6. X is greater than negative 6. There's no equal sign, right? So let's draw here the parentheses because negative 6 is not included on the sets. And everything greater to the right side of negative 6 is included. Now let's find the union. The union is going to be equal to, and draw the line here, and 0. Try to draw 0 aligned. See, the same alignment goes from negative infinity to positive infinity. Every number that is either on one set or the other set is going to be now included on the union. And then we have thus negative 6 is included in one of the sets. See, this parenthesis here indicate that negative 6 is not included, and it's not here as well. So negative 6 actually is not included. We draw here this parenthesis, and everything that's greater than negative 6 is included in and between negative 6 and 0 is included in just one set, right? Since it's the union, it needs only to be included in either set, in one set. So this is part of the union. And everything that's greater than 0 is in both sets, and also included, also is part of the union. So the union, let's represent here in interval notation. So parentheses is going from negative 6 all the way to positive infinity. Okay? This is the result of the union of these two inequalities. 5 times x minus 1 greater or equal to negative 5, or 5 minus x is less than 11. The result is this interval parenthesis negative 6 comma positive infinity parenthesis. And finally, we have here the last example for this section, and the example involves the union. You have to solve the union of two inequalities, which are, the inequalities are negative 2x minus 5 is less than negative 3, or, and this is the word that means union, right? 5x is less than 0. Let's solve for each inequality first, and let's add 5 on both sides. Add 5 on both sides. Then you have negative 2x is less than negative 3 plus 5, true. Then divide by negative 1 on both sides, or multiply both sides by negative 1, doesn't matter. Don't forget to flip the sign of the inequality. Then we have this, flip it, and we have, don't divide by negative 1, divide by negative 2. Divide by negative 2 to simplify. Divide by negative 2. Okay? Then you're going to have x is greater than 1. Negative 1. 2 divided by negative 2, negative 1. On the other side, we will have 6x less than 0. Divide both sides by 6. Means x is less than 0. Now let's represent the graph of each inequality. And first we're going to represent this one, this inequality. Draw the line. Is going to be the graph from negative infinity to positive infinity. And here is 0. X is greater than negative 1. Negative 1 is here. Let's represent this in green. See, we don't have equal, so parentheses, and everything greater to the right side of negative 1 is included on the set. Let's represent x is less than 0, the other inequality. I'm going to represent underneath, draw another line, make 0 here aligned, 0 here, negative infinity to positive infinity. Let's represent in orange. Less than 0, there's no equal, so parentheses, everything less than 0 to the left hand side of 0 is included. And this is interesting because now we are trying to find the union. So we is the union of this set represented in green with that set represented in orange. And every number that is included in either one or the other set is going to be part of this result of the union. And what's interesting here is that let's start on this first one. Does everything greater than negative 1 between negative 1 and 0, between negative 1 and 0, is it included in one of the sets? Yes, actually it's included in both sets. Let's represent in purple. So this, yes, is part of the union set. Everything greater than 0, including 0, is in one set. Well, 0 is not here because there's a parenthesis, right? It's not included on the second set, but is included on the first set. So 0 and everything greater than 0 is in one of the sets, so is in the union as well. And what about the numbers that are less than negative 1? Negative 1 is here. Actually, they are not included on the first set. They're not part of the first set, but they are included. They are part of the second set. So yes, they are part of the union as well. And what we see here is that the result of this union, the union of negative 2x minus 5 is less than negative 3, or 6x is less than 0, is going to be the, represented here in interval notation, the interval between negative infinity all the way to positive infinity. And this means all the real numbers, are a result of this union. And this is a wrap for section 2.5. We are ready to move on to the next section of this course.